This will be video 4 for the 2011 Form A test, and a little twist on this question. Normally we have a question where they give us a picture and it's the derivative of g here, but notice they've defined g a little bit differently. So we're going to have to pay a little bit more attention how we do this. So let's go ahead and get started with A here. So g of -3, if we just do this algebraically, it means replace all of the x's with -3. So that means we have 2 times -3 plus the integral from 0 to -3 of the function dt. So that makes -6, and then plus, I need to find the area under the curve, from 0 to -3 is going to be the quarter of a circle, except notice we're integrating backwards, so it's actually going to be a negative number. So it's going to be 1/4 of pi r, and the radius appears to be 3 squared. So I get -6 minus 9/4 pi. Alright, I guess that's it. So there's the first one. And then it says find g prime of x, so the function, and again normally that's just f, but this time if you notice the derivative of g is actually going to be term by term 2 plus, now we do the antiderivative, we do the derivative of the antiderivative, and so that's simply going to be f of x. And now they want me to evaluate it at -3, so that's simply going to equal 2 plus, and then f of -3, 1, 2, 3, that's 0. So the answer is 2. Part B. Determine the x-coordinate of the point at which g has an absolute maximum on the interval. And notice the interval includes endpoints. So what we need to do is figure out when the derivative of g equals 0, and then also test endpoints. So I'm going to need to find g of -4. I'm going to need to find g of 3. And then I need to find when g prime of x equals 0, which is going to be 2 plus f of x equaling 0, or whenever f of x equals -2. So we come look at the graph, and we see that f is never -2 over here, but f is going to equal -2 over here someplace, right about there. So let's see, the slope of this thing is 2, so we're going to go down 2 and over 1. So let's see here. Alright, so we're at a half here. Oh, this is kind of annoying. Let's work it back. So I'm going to go over 1 and up 2. So that's this point. Alright, I think I just need the equation of this line and plug it in. That'll be the easiest. So I already have the slope. The y-intercept is 3. So the equation of this line is y equals -2x plus 3. And now I just want to know when is it -2. So that's going to be -2 equals -2x plus 3. So subtract 3, and -5 equals -2x, so at x equals 2.5. Alright, so I'm going to find g of -4, g of 3, and then g of 2.5. Okay, I'm going to erase this mess because it's in my way here. g of negative 4. I need to plug in negative 4. So looking at g, that's going to be 2 times negative 4 plus the integral from 0 to negative 4 f of t. So that's going to give me negative 8 plus, and now I need to find the area under the curve from 0 to negative 4, which is going to be, again, we're above the axis, but we're going backwards, so this is actually negative. So that was a number, it was negative 9/4 pi. And then we're going to have a little bit of positive, and that's from a quarter of a circle with a unit of 1. So plus a quarter of pi r squared, so that's just going to be, again, r is 1, so we just get times pi. So that means we get negative 8, and then negative, that's going to be negative 8/4, which is negative 2 pi. So that's negative 8 minus 2 pi for g of negative 4. It's very messy. G of 3 should be a little easier to find. With the area under this triangle, and then the area under another triangle. This is 1.5 wide and 3 tall. This is going to be 1.5 wide and 3 down. So the area under the curve is 0. So when I again pay attention to the equation, I get 2 times plugging in 3 plus, we've determined that the integral is 0. So that guy's going to equal 6. Alright, it's very messy. And then I got to find g of 2.5, which is going to be 2 times 2.5 plus the integral from 0 to 2.5 of f of t. So that's going to equal 5 plus, so the area under this triangle is going to be 1/2 of the base, which is 3/2, times the height, which is 3. And then we've got, how far are we going, to 2.5? 2.5. So that's going to be another triangle, except this time it's going to be negative, with a base of 1 and a height of, let's see, I lost my place, at 2.5, 1, 2.5, or 5/2, plug that in, that's going to be negative 2. Okay, so we get 5, and we get 9/4 minus, and I already accounted for the negative here, so this negative is redundant, or this one is, one of the two. The reason it's negative is because the height is negative. So I almost messed myself up right there. So 2 times 1/2 is 1, so it looks like we got minus 1. So the answer is going to be 4 plus 9/4, or 4 plus 2 1/4. So 8 1/4. Whew, okay, what did the question even ask? Determine the x-coordinate where g has an absolute maximum. So here's 8 1/4, here's 6, and then here's negative 8, and that's nowhere near going to be the biggest. So it looks like my answer is going to be g of 2.5. Ugh, that was awful. Alright, part C. Find all the x values, not including the endpoints, for which g has a point of inflection. Give a reason for your answer. Alright, so part C. G is going to have an inflection point when G double prime equals 0 or is undefined, and also switches signs. So the derivative of G, we already found earlier, was 2 plus f of x. So if you think about what that means, the 2 on the outside of the f of x simply means that the derivative of G is this picture, just everything shifted up 2, which might have been helpful for me to think about on the last question. But either way, I'm looking for wherever the slopes of this thing change. So here we're positive, positive, positive. Right here we switch into negative. So 0 appears to be a point of inflection. And that should be it. So part C, the answer would be x equals 0 because that is the only place where the slopes of G prime change sign. Okay. Now we want to find the average rate of change of f. So this is f. So I just need to find the average rate of change of f from -4 to -3. So this is what they're asking me to find the average rate of change on. And so all they're simply asking me to do is to find the slope from here to here. Then they're going to ask me, is there a place where the derivative equals that average that we got? And it's possible that there isn't. Oh, here it says there is not one. Okay, good. So we don't have to try and find it. And they want to know why that doesn't violate the mean value theorem. And that's because right here at 0 we're we can't take the derivative. So f is not a differentiable function over its domain. Therefore, we don't violate the mean value theorem. Okay, so I just need to find the slope between these 2 points, and that's some pretty basic Algebra 1 math there. So -4, -1, 3, -3. So part D, -4, -1, and was it -3, -3, I think. Yep. 3, -3, excuse me. So the slope equals -3 minus a -1 over 3 minus a -4. So -2/7. And then I'm not going to write it because I'm almost out of time. But basically I would just write simply because, again, why won't there be a point? Because it's not a differentiable function. And that should do the trick. Alright, I'm going to take a look at the scoring guide for this one. And let's see how we did. This was kind of an unfun question. Excuse me, it's going to beep. Okay. Okay, -6 minus, I don't even remember what we got. Let's take a look. Oh yeah, this is very messy. -6 minus 9/4 pi, that's what we got. And oh, there was 3 parts. And then G prime was 2 plus f of x, which we got. And then the answer was 2. Alright, so we got 3 points on A. B, we get 3 more points. G prime of x equals 0 when f of x is -2, which is what we found. This occurs at 5/2. And that's it. So then they looked at slopes instead of finding the values, so they didn't do quite as much work as we did, but it required a little more explanation. So They found the same answer we did, of 5/2, and that part wasn't much fun. Part C, the second derivative, which is equal to f prime of x, changes sign only at x equals 0, therefore that's the only point of inflection. So they went one step further than we did, and they went to the second derivative and talked about it changing signs. I stayed at f and talked about the slope changing signs. And here's the average of -2/7, and again, must be differentiable, and it's not. Okay, that's the end of video, I guess this is 4.